Hello, this is Josh Brinson, and this is my Game Engine 2 final demo. Starting off, we are in my converter code. We're in main, and you can see a bunch of commented out test code that I use to run in debug mode. The important thing to care about here is this function, find anim data. Well, it's the function that controls everything else. So we go here, and then we go to display pose, from which we get the inverse bind pose of the skeleton. I figured it would be useful to have the bind pose for skinning later on, but I don't really use it for much as of right now. But I do have it. It actually did end up kind of throwing a wrench into things for me, which I'll get back to. I go into display hierarchy after that, and this is where I map where I index my skeleton. So I go through, and you'll notice I've got a conditional here, if pose. But I go through and I find where each node is and where its parent is, and set those values into these index variables on my joint structures. Just build the whole hierarchy there. If I don't have a bind pose, I had to add this because human does not have a bind pose. I did all of the work with Teddy and then found out human is completely different and screwed up a basic assumption that I had about my skeletons. And so if I don't have a bind pose, I go in here and I basically just have to build my skeleton vector from scratch, and I create the indexes as I go. I'm always adding to the end of the vector because I don't want these to move once they're in there. It would be very bad to get things pushed back and end up with my, telling one node that its parent is here, and then another child node of that same parent gets a different parent index because that parent has moved. That would not be good. So that's what I do here. And then I go into display animation, where I collect all the data about, for every animation I collect the name and the number of keyframes and the frame rate, and then I build the animation stack, the list of keyframes. I go through, and for every keyframe I get the info from every node. So I get the joint pose for every joint in the skeleton at every keyframe for every animation. The data structures that I use to store all this, I've got joint, which has the bind pose but also like the indexing information. I've got a skeleton structure, which just has a pointer to a joint array and the number of joints. The joint pose, which is the SQT, and then a keyframe, which houses a joint pose array. An animation stack, which houses a keyframe array, as well as the number of keyframes and the skeleton it's associated with, and this other information. And then some headers for my file writing. So from here we'll go into the engine code. We're in global state right now, and most of this is old code from milestone 1, not a lot of exciting stuff happening. Load animations is where I read the file and pull in all the data, creating skeletons and adding them to my skeleton manager, and creating animation stack structures and adding them to my animation mint. Once I've got all of my data loaded up, then I can start creating objects. I'm creating a warbear here. We'll see him in a little bit. So the animation controller really kind of runs the show for animations. And I go in here, I set up a skeleton. There's all kinds of news being called around here. I go through, I create everything to do with the skeleton. I associate the skeleton, I get I start with the inverse bind pose, and in the case of skeletons that don't have a bind pose, such as human. I actually went through and manually created or I just set this variable to an identity matrix for everything, so that there would be a matrix here to make sure this didn't blow up. Um, Eventually it would need to be replaced with something to get skinning to work, so I'm not sure how that would work yet, but I wanted to make sure my framework here stayed intact. So I go through, I create an animation object for every joint, and then I add it to a tree that is on the animation controller. So this might actually work better if I show what the animation controller looks like. It is here, it's got an animation object array, which is animation objects are my graphics object specifically for animations. It's got a tree of them and a pointer to the root node of that tree, because the PCS tree actually has its own null object root. But this is the root of the animation, so the root node of Teddy or of humanoid. Then I've got the skeleton, number of joints, current animation, the time variables, keyframe, all this stuff. The control scale, control SQT here is used, I'll show you where, but that's what the matrix quad and the matrices and the quad that I'm passing in here are. Those go to the control variables. So once once I create all of my animation objects, then I'm ready to start drawing them. The animation, well, go back to global state. In my game loop, I've got an update for my animation control manager. And it goes through and it updates each node, which are animation controllers. And this is where all of the magic happens to make things animate. So I've got booleans here to check whether I'm reversed or paused or looping, etc. And I go through and I calculate the time difference multiplied by whatever the speed variable is. These are both, well, this one is defaulted to 0.5 and this one to 0.25, I believe. Let's double check that. Yeah, 0.5 and 0.25. And that's just to give me two speed settings for the demo. And then if I get to the end of an animation and I'm not looping, then I will pause. So I go do all this, and then I go and process animation. And that is where I actually take this and I do the lerps and slurp to figure out. First I go and I figure out what two keyframes am I between. So if my time says I'm at keyframe 10.2, then I need to know that I'm, lerping and slurping between 10 and 2 and by point, or between 10 and 11 and by 0.2. So that figures that out up here. Then I go through, do the lerps. This is where those control variables come into play. So for the parent index, I multiply by these controls. So that's what lets me set the position, rotation, and scale of the entire animation, is that I go through and I say, okay, this is where I want Teddy to be, or this first Teddy at this rotation and at this scale. And so this way I've given them all a different T so that they'll all be in a different spot on the screen. And then the Teddy I scaled by 0.3 and the humanoid by 0.2. So let's go ahead and take a look at what it looks like then. Alright, so here we've got, I'll put it in the center, 5 skeletons, and a warbear right there. We can get a close-up of warbear on this camera. He actually caused me a lot of problems. I'll talk about that in a little bit. But we've got our skeletons. The teddies are in the front here with fewer nodes, and then the humanoids with their many, many, many pyramids. So you see this guy is red here. That means he's currently selected, and I can do stuff. I can pause his animation. I can set him to go in reverse. We're going to reverse something else, though, because he, tell is lazy. Here's the running guy. Let's reverse him. Pause. Put him forward again. I'm going to turn off looping. So he got to the end of his animation, was not looping, so now he's paused. I can unpause him, and I can just keep doing this forever. He'll always stop at the front until I make him go again. Then I can slow him down or speed him up. Oops, I hit the loop button. Now he's in slow-mo. And he can go in reverse in slow-mo or normal speed. So you can see I can toggle between all of my skeletons to do different things with them. I can also toggle the animations, so let's find this punching guy. Now he's going to get shot like the other one. And now he's running. Let's get a different time, so you can see the running animations. They're instanced properly and happening at different times. And teddies can change animations too. So there you have it. I believe that is all of the features. I think I've showed them all. So I hope you liked it. Oh, the warbear problem. I wanted to mention that. So it's an interesting problem I had. I was creating this warbear mostly because, like, while I was getting everything to draw, sometimes it wasn't on screen, and I wanted to make sure that I knew, had some help finding the problem. So I put warbear out there, just so that, like, if warbear was drawing, then I knew, it wasn't a problem with the camera, it wasn't a problem with whatever else. Warbear could draw and do all his things. And so I just sort of left him there as I was adding other stuff in and kind of ignored him. And then it turned out, like, when I was going through and toggling through these guys, I changed their color, obviously. And I had a problem where when I did that, I was going through the graphics object tree and going to siblings, doing a depth first search, but I was starting with the root node of the model, which was a sibling of warbear. So warbear is a different object type. He's not an animation object, he's a generic object. And so when I tried to set the light on him, well, generic object is not as big as animation object. So I was setting some random 4 bytes, which happened to be, at the time, some of the animation node pointer variables in my animation stack. So I would blow those pointers away, and then it would go and try to set them and blow up on me. So warbear there caused me a lot of grief for no reason. But yeah, that's all of the features. They can go forward and backward, they can play, they can pause, toggle through animations. I've got instances. They go fast, they go slow. So all done. Really did not think I was going to get through this one, but I seem to have managed it. Thank you.